Okay, so unfortunately the last video malfunctioned and I lost half of it. So it cut out as I was going through this question at 4C. As you can see, I've completed D and part 1 and 2 as well. And I got mostly through E. So I'll just explain quickly what I did to work out D. So for D, we are using the sine rule. And I'm sure there's another way that you could solve this as well. But using the sine rule, it's always a good idea to draw our second, another diagram so you're clear, copying the information from the original diagram. So we want to work out the length of AD, which is this side here. So I've copied that in. Using the sine rule, we can substitute in our values, we can work it out and then put it from our calculator for significant figures. So part 2 is asking us the area of ABD. So ABD, so that's the bigger one there. So again, draw the diagram of what you've got, ABD, fill in the bits that you do know. To be able to use the area rule, which is here, what we need to do is obviously we need to work out this area, this angle, and we can work that out because if we know that's 35 and that's 77, that must be 68. So we've got the opposite side we don't know of 68, but we can use this as A and B, and this would be sine C. Substitute those in, use the calculator to get our final answer. That brings us on to E, and I want to spend a little bit of time because it's kind of a trap that people get in and we kind of have people get confused by. First of all, the question is the area of triangle AED, which I've pre-drawn already. So AED, which is that green triangle, is 12.3 centimeters squared, and you can see I've written in 12.3 centimeters squared. Corrected 3 significant figures. Use the similar triangles to calculate the area of BEC. So you can see the yellow triangle is a similar triangle, and the reason for that, I might use this rainbow one, is that you can see this angle and this angle are vertically opposite, so they must be the same. We already have proved that the 35-degree angles are the same, but also this angle here and this angle here must be the same because they share the same arc. So it's the same rule we used for 35 as well. The other thing pointing out that points D, A, B, C would create a cyclic quadrilateral with this line. It's not relevant for this question, but it could be for a question that you have to do. So a little side note, and the important thing, and I think the thing that would trip up most people, is that we are talking about area in this question. The reason why that trips people up is that we're familiar with using scale factors in 1D, but when we use area, suddenly scale factors get larger. So it's worth sort of pointing out, first of all, if we're talking about one dimension, and we have a scale factor of 3, it's relatively straightforward. So if I start off with 2, it means my second line, if it's a scale factor of 3, must be 6. So that's length. So in 2 dimensions, so for instance, a rectangle, which is area, and a scale factor of 3, means that factors in length in one direction. So if this is 2 and this is 2, it means my scale factor of 3 must be 6 by 6, which is 36. But my area of my first one was 4. So while the sides are in a scale factor of 3, what we actually have to multiply in area is that we actually have to multiply 4 by 9. So remember, the reason for that is if the scale factor is k for length, then for area it's going to be k squared. And it also makes sense if we're thinking about 3D, that if we are doing volume and the scale factor is 3, then it would be k to the power of 3. So you would have to times by 27. So sorry, I'll do that in a different color. So times by 27, this one we're timesing by 9, this one we're timesing by 3. So bring that back to our question. So if so we need to work out the scale factor between the triangles, and if we look the sides that we can compare, so we can compare the length of this side and this side. So for our scale factor, we are going to use BC divided by AD will equal our scale factor because they're corresponding sides. So that would be 10 divided by 11.89. And if we do that on our calculator, I may even still have the number there. So it should be 0.8410. 0.8410. All right, but because it's area, it's going to be, so to work out the area of triangle BEC is going to be equal to the scale factor k squared times the area of triangle AED, which means we are going to use 0.8410 squared times 12.3. So we can do that on our calculator. So we can take that answer and square it. It's probably worth pointing out that's 4SF. Take that answer, square it, and then times 12.3, which gives us our answer 8.7004 SF. Okay, and then that's our final answer.